Okay, so 80 people were asked their favorite genre of music was pop, classical, folk, or jazz, and these are the results as shown. First question is, what's the probability of randomly selecting a person who is female or likes jazz? Well, this is just review from the past, so probability of female or jazz. It means any one of these people here or these ones. And so I could add 42, which is all the females, and 15, but then subtract away the 7 because it was counted twice. So that's going to be 15 plus 42 minus 7 over the total of 80, which is 50, which ends up being 5 over 8. Okay, just a review of probability. So now we want to carry out a chi-squared test at the 10% significance level, so alpha is 10%. First step is we want to recognize this is a chi-squared test of independence. We want to know if they're related, these two. So we want to write down the null alternative hypothesis. Well, for chi-squared test of independence, the null hypothesis is always the name of the test. So gender and musical genre are independent, and the alternative is they are not independent. And it says show that the expected value for a female liking pop is 21. So if I'm going to take a look at that, females liking pop, I know that I'm looking at females and pop, so I'm going to take the total of pop. I take 40 times the total for female, 42, and I divide that by the grand total of 80. And so I get 40 times 42 divide by 80, and I get, so this expected value is actually 21, because this is the proportion of people who like pop, and if this is the proportion of males and females, well, we should have 21 females liking pop. Okay, so now use your GDC to find the full value of expected values. All right, so make sure that we say that's 21. So if I go to my GDC, if I go to my matrix, here is A. I've already entered it into A, and you can see all these values. And so if I want to find the expected values, I actually do the chi-squared test, and it will put it into B. And if I draw it, I get that. Let's take a look at my expected value, look at B. And when we look at B, we can see that folk is less than 5. And so that's a problem. What do we do? Because one of our conditions is this all expected counts have to be larger than 5. And so what we do is we combine the smallest one. So we're going to combine these two categories here. And so when we do that, if we consider that we're going to put the folk and the jazz together, I can see that there's going to be 11 folk and jazz. There's going to be 14 folk and jazz here. And so the total is going to be 25. And so then I go back to my matrix. I'm going to edit A, number 1. It's going to be a 2 by 3 matrix this time. And this value is 11. The next value is a 14. Enter. So when we have this, our new degrees of freedom, for this case here, degrees of freedom, we know is the rows. We have 2 rows minus 1. It's 2 minus 1 times the columns. Well, there's 3 columns, 3 minus 1. And so degrees of freedom will be 1 times 2 is 2 again. Write down the degrees of freedom for the new table. Find the chi-square statistic and the p-value. So we're going to go statistics to the test. Again, it's C. I have changed my table for observed A. It'll put it in B. I'm going to calculate it, and I can see that my chi-squared value is 1.16 to 3 significant figures, and the p-value is equal to 0.559. And so is the null hypothesis accepted or not? Well, this p-value is large. Okay, so we fail to reject. So we fail to reject H naught as the p-value is bigger than alpha, and claim insufficient evidence that genre and gender are not independent. Basically, we think they are dependent, as we fail to reject the null hypothesis. And so the reason for our answer is the p-value and the alpha. And so there we go, our chi-squared test of independence.